All right, algebras, let's take a look at this graph. J of x. Is it a function? Does it pass my vertical line test? When I run this over, I'm curious about this point here, but because this is an open dot and this is a closed dot, yes, it is a function. There are no repeats in the domain. Is it continuous? Can I take my pencil and trace the whole graph without picking it up? No. Is it one-to-one? It fails the horizontal line test, so no, it is not. Let's talk about the domain. Remember, the domain is what x values could go in. Well, look, this arrow tells us that everything from negative infinity all the way up to and up, including everything, nothing is left out. So negative infinity to positive infinity. Here's an interesting conversation about the range. Here, our range is equal to 0, and our range is equal to positive 1. So that's an interesting conversation about how every output value is either a 0 or a positive 1. Is it ever increasing? No. Is it ever decreasing? None. And where is it constant? So get this, it's constant throughout our entire interval. It just happens to change what the output value is, but here's where it's constant, and here's where it's constant. What is our x-intercepts? Hey, this is a tricky one too. So all of the x values that are less than 0 are all the x-intercepts. This entire line here is sitting on the x-axis. So all of those x values that are smaller than 0, that's the intercept. My y-intercept, over 0, up 1. Here's that point here where it crosses the y-axis. What is my maximum value? 1. What's my minimum value? Is going to be a 0. Now here's an interesting conversation. As x approaches negative infinity, where is the output? It's at 0. As x approaches positive infinity, where's the output? It's at 1. How did you do? All right, check in on the next graph.